In this video, we're going to do two more examples in analyzing parallel and series circuits. So take a pause and then draw this diagram that I have out of a circuit along with the chart on the side. What we're going to do is find the current that runs through each resistor and also the potential drop. Okay, so we're going to get started in analyzing this circuit. So on the side in the chart, I listed each resistor. And we're going to try to find the current that goes through each resistor as well as its potential drop. The first thing we're going to do is find the total resistance, RT. And this is going to be the resistance of each parallel pair and also the resistance from the one that's 6 ohms. So in the last lesson, we learned how to find the resistance of a parallel pair in the circuit. And it's going to be the reciprocal, so 1 over 10 ohms plus 1 over 15 ohms from our first parallel pair, and then we inverse that. Then we have another pair, which is 5 ohms and 8 ohms. And inverse that. And lastly, we have the 6 ohms that is not in a parallel, but it's in a series. Okay. Now we're going to simplify this. So 1 over 10 plus 1 over 15, and then taking the reciprocal of that is actually 6. 1 over 8 plus 1 over 5, and then reciprocal of that, and that's 3.08. So our resistance altogether is going to be 15.08 ohms. The other thing we can find is find the total current, which is calculated as potential difference total over the resistance total. So our energy source, the potential difference, is 20 volts. And we just found RT, which is 15.08 ohms. So then the total current is 1.33 amps. Okay, now we have quite a bit more information to help us analyze the current in each resistor. Let's focus on the 6 ohms one first. It's the easiest one. Your current is going to be the total current because this is in a series. So it'll be 1.33 amps. So I can fill that in here, 1.33. And then we can look at its voltage as well. So the potential drop is I times R. So I is 1.33, we just found that, and then R, of course, is going to be the 6 ohms. So the potential drop is 7.98 volts. Okay, we finished the resistor, that's 6 ohms. Now let's look at each pair. So let's do the 5 ohm and 8 ohm pair right now. We can find the potential drop first, which is I times R. I is the current total, which is 1.33. And R, we actually found that in part 1 for 1 over 8 plus 1 over 5 inversed. That would be our R. So that's 1.33 times 3.08, which is 4.1 volts. So that is our potential drop for 5 ohms and 8 ohms. So I can write that in here for 0.1. But then the current that runs through each is a bit different, and we're going to calculate that separately. So we have the 5 ohm one and the 8 ohm one is calculated as V over R. So V we just found is 4.1, and then your resistance is 5 for this one, is 0.82 amps. And then for other one, 4.1 over 8, because it's 8 ohms, and that's going to be 0.51 amps. And we can fill that in our chart. So 0.82 amps for the 5 ohm one and 0.51 amps for the 8 ohm one. We're going to do the similar sort of thing, but for the 10 ohm, 15 ohm parallel. So first we're going to calculate the potential drop, which is I times R. I is 1.33 and R is 1 over 10 plus 1 over 15 and then inversed because they're parallel. Or in other words, 1.33 times 6, so potential drop is 7.98 volts. We can fill that in here. And then we're going to find the current that runs through each resistor. So for the 10 ohm one and the 15 ohm one. So I is V over R. V in this case is 7.98 and R is 10. So that is 0.798, and the other one is 7.98 over 15, which is 0.53. So for the 10 ohm one, we can just round it a bit, so we can say that's 0.8, and for the 15 ohm one, the current is 0.53. And then we filled in our chart. Let's do one more example, slightly more complex. So go ahead and draw this circuit with the chart to complete. We're going to do one extra calculation, just finding the power, and that's calculated as I times V. And if you take a look at this circuit, we have a parallel circuit with 10 ohms, 12 ohms, and 14 ohms. But we have another one if you were to combine the 10 ohm, 12 ohm, 14, and 4 ohms as the upper part of the circuit, and this is parallel with the 8 ohms. A bit complex here. Alright, so let's get started in trying to complete this chart of information. I'm going to separate kind of the upper part of our circuit, and then our lower part of the circuit is just going to be 8 ohms. So I'm going to find the resistance total for the upper part of the circuit. So I'm going to ignore the 8 ohms for now. So just looking at the upper part of the circuit, we have the parallel of 10 ohms, 12 ohms, and 14 ohms. And I'll inverse because this is again a parallel. And then beside that we have 4 ohms for our resistor that is in series with it. So this is what we're going to calculate just for the upper part of our circuit. And 1 over 10 plus 1 over 12 plus 1 over 14, and then inverse is 3.93. So the resistance total just for the upper part is 7.93. Now we can find the total resistance for the entire circuit, because this 7.93 ohms is parallel with the 8 ohms. So this whole thing here is what I just calculated, the resistance total for all of that is 7.93, and it's parallel with this 8 ohms. So that's how I'm going to calculate the resistance total. That's going to be 1 over 7.93 plus 1 over 8, all inversed because they were parallel with each other. After this calculation, we're going to get 3.98 ohms. And this would be our actual answer. The other thing we can find now is the current total, because that is potential difference over our resistance total. So our potential difference is 20 volts coming from here, and the resistance total, we just found that it's 3.98 ohms. So our current total then is 5.03 amps. Okay, so now we have some extra information to help us break this down even more for each resistor. So let's just maybe focus on the 8 ohm one for now, resistor, to find the current that runs through it and also its potential drop. So for the current that runs through it, we're going to first determine what our potential drop is, and it's going to be the same as our potential difference, which is 20 volts, because this is in a series. It's in a series because there is a path that can just go like this without ever having to touch any of the other resistors. Okay, now we can calculate the current, which is 20 over 8, and that's 2.5 amps. So we can fill this in our chart. So for our 8 ohm resistor, V is 20, and our current is 2.5. If I want to find P, it's going to be 2.5 times 20, which is 50. The next one. Let's just focus on the upper half. And that upper half again is the 3 that are parallel, so the 10 ohm, 12 ohm, 14 ohm, and then we also have the 4 ohm. So for the upper half, we're going to look at R for our resistance total, and we found that already. That's 7.93. We're going to have to use that information again, and we're also going to find the current that is in the upper half. It's going to be calculated as the total current minus the one from 8 ohms. Then whatever's left over is just going to be the upper half. So think about this again. We know the current total for this entire circuit. We already figured out what the current is when it goes through the 8 ohm resistor. So whatever's left over is going to be the current for the upper half. So that would be 5.03 minus 2.5. And this is 2.53 amps for the upper half. So this information we just found can help us with the resistor for 4 ohms right away. We can find the potential drop, which is I times R, So we just found I for the upper, it's 2.53 amps, and then our resistor is 4 ohms. So then for the 4 ohms, the potential drop is 10.1 volts. So we can fill in some of this information for the 4 ohm one. So we have the current, which is 2.53. And then we found the potential drop, which is 10.1. Then our power, which is I times V, is 25.6. Just running out of room here. So the next thing we're going to do is try to figure out the parallel circuit one. That's 10 ohms, 12 ohms, and 14 ohms. We need to find the potential drop for that parallel circuit portion of it, and then we also need to find the current that runs through each resistor. So we're going to find V in the parallel section of the circuit. So for V, it's going to be the potential difference, the initial one, which is going to be the 20 volts, minus the volts that the potential difference we found for 4 ohms. Because this was calculated from the upper half. So remember, the upper half is all connected with each other. We found the potential drop from just the 4 ohms. So then whatever's left over is going to be the parallel section, because if you look at this pathway, once you get to here, it has those 3 choices. And then we have to pass through the 4 ohm one. Okay, so if the potential difference was 20V to begin with, and when we passed through the 4 ohms, it was 10.1 volts, that means whatever left over is going to go through the parallel section. Okay, so then our V in the parallel section is going to be 20 minus 10.1, which is 9.9. And that is our potential drop in each parallel, in the parallel section for each of them. So that's 9.9. Then lastly, we're going to find the current that runs through each. So we're going to look for the 10 ohm one, 12 ohm one, and the 14 ohm one. And that's calculated as V over R for each, where V is 9.9 divided by the ohms of that resistor. So the 10 ohm one is 0.99 amps, the 12 ohm one is 0.83 amps, and the 14 ohm one is 0.7 amps. Here's 7:1. And we're going to just fill in the chart here. So the 10 ohm one was 0.99, the 12 ohm one is 0.83, and then the 14 ohm one is 0.71. Then lastly, you can fill in the power portion, which is I times V. So 0.99 times 9.9 is 9.8. I times V here is 8.2. I times V here is 7. And then that's it.